So hello students, we are starting with the second unit of the subject world-class manufacturing. Today's session is cutting-edge technology. Syllabus for today's session, we are going to learn about manufacturing excellence and competitiveness. Then what is world-class manufacturing? Hall's framework of value-added engineering. Then Schronberg's framework of world-class manufacturing. Gunn's model of world-class manufacturing. MASKELL's model of world-class manufacturing, and America's best plants model of world-class manufacturing. And lastly, we'll learn about the famous Malcolm Baldrige Quality Award. So this is the syllabus for second unit. So we'll start with manufacturing excellence and competitiveness. This is the small unit with the less syllabus. Manufacturing involves technology that has two aspects of technology of the product and technology of the process. The technology of product determines the qualities that customer look for in the marketplace, that is performance, features, appearance, attractiveness, etc. However, its price, quality, reliability, etc. are determined by the technology employed in making the product, that is manufacturing process. One has to be good in both to be in a competitive world. So the companies need to achieve product excellence as well as the process excellence. A cosmetically brilliant product that fails at the first time you put it to use will hardly have any buyers, as also will a robust and well-built product which are hideous in appearance and not user-friendly. So product technology along with process technology go hand in hand. Both product technology and process technology can be purchased. However, we put it to use and exploit it to our advantage determines our competitiveness. Furthermore, manufacturing is merely the conversion process that takes place on the shop floor, but a whole lot of activities preceding and following it, till the product leaves the factory. Thus, manufacturing is more comprehensive activity that includes activities such as materials management, equipment and tooling, along with fabrication of parts, then material handling, assembly, quality control, maintenance of the production plant, machineries, planning, information system, and human resources as well. Each of these mentioned activity is important and must be done well to achieve manufacturing excellence. But excellence in all the manufacturing activities individually is not sufficient. Overall excellence, along with the guaranteed success, is important. Again, one-time excellence guarantees only one-time success. So, for continued success in a competitive market, continuous improvement in all the areas of activity is essential. Without it, one may have to the best technology and the most modern plant and machineries, but still someone else may be turning out a better product at the lower cost. To achieve the excellence in manufacturing, according to Prabhala in 1994, a manufacturing manager should keep in mind five goals. So to achieve the excellence in manufacturing, the five goals are: throughput should go up, inventory should come down, operating expenses should come down, cycle time should be reduced or come down, and yield should go up. That is, productivity should go up. Now, next part is what is world-class manufacturing? Manufacturing is a bedrock on which the economic wealth of the nation is built. The Industrial Revolution, first in UK and later in Europe and US, shifted manufacturing activities from the homes and cottages to the factories equipped with power-driven machineries and management from owners to professionals. The UK, which pioneered the Industrial Revolution, lost its competitive edge to Europe, particularly to Germany and to the US, and failing to upgrade its manufacturing technology and commercialize its scientific research. American manufacturing dominated the world in 1940, but since then, many countries, especially from the Southeast Asia and the Far East, have advanced a long way, giving America a tough competition. There may be a number of reasons for this. According to Gunn in 1987 and Schonberger in 1986, listed out American manufacturing dominated. So there are various reasons for that. So these companies had a newer plant and equipments. American firms had short-term focus and therefore did not reinvest in the new plant and equipment. So American manufacturing gets dominated by the other countries. That the reasons we are listing out. So American workers demanded high uh, wage rates. These countries use unfair trade practices in market access, sharing the technologies or the other ways. Young American did not want to have a career in manufacturing. American did not want to work anymore, etc. Most of American firms measure their company's progress against their own performance in the last year rather than benchmarking it with the competitors. And the top management of many of these companies did not have a manufacturing background, but they came from the marketing, finance, etc. backgrounds. So more recently, disappearance of a whole lot of industries in the US, such as consumer electronics, is a symptom of malaise that results when the manufacturing takes a backseat. The loss of competitiveness in the American industry in a number of segments such as automobile, machine tools, cameras, semiconductors is less due to unfair trade practices adopted by Japan or more due to neglect the essential of competitive manufacturing. Thus, with the increasing level of globalization and competition, American firms were constrained to regain their competitiveness in the global markets. With manufacturing capabilities much stronger worldwide, it was not possible for US to match every other region in every product line. However, production of a large stable of products competitive in the global market was necessary to maintain an equitable trade balance with other developed nations. This improved competitiveness in its broadest context was referred as manufacturing excellence and was to be dominated by simultaneous improvements in manufacturing performance as well as business performance through indicators such as productivity, that is value added per employee, cost reduction, and market share in the world market. If a firm continues to excel in manufacturing, it may dominate the world markets, in which case it would be called a world-class manufacturer. The goal of world-class manufacturer efforts include maintaining market share, improving profitability, and improving firms' ability to compete in a global market place. So this is the diagram of manufacturing excellence and world-class manufacturing. So whereas the general principles of improving the manufacturing performances are well known, in order to establish the relationship between manufacturing performances and the business performances or world market dominance, there was a need to develop a conceptual framework to represent the relationship. A number of manufacturing researchers consultants have published such frameworks, and some of the more prominent and recent ones are described here. First important is Hall's framework of value-added engineering. Now, according to the author Hall in 1987, manufacturing excellence is attained by value-added manufacturing, which is based on the principle that purge anything that does not add value to the product or service, whether material, equipment, space, time, energy system, or human activity of any sort. Shigo in 1981 gives a summary of seven West, where West is everything that does not add value to the product or service as far as production is concerned, as far as customers are concerned. These seven weights West and their methods of elimination are described on the screen. So first weight type is waste of overproduction. So overproduction is also a waste. So production which is not needed and still the companies are producing the products. How to eliminate that? Reducing the setup time, synchronizing quantities and timing between two processes. That can be done and overproduction can be eliminated. Now, waste of waiting. Suppose there are few machines and there are some in-process inventory or work-in-process inventory, and that inventory waits for the machines to perform the operations. Or there are operators, they are sitting idle and they are perform the task on the machineries, or maybe they are waiting for the inventory to come. Such type of waiting may be for the workers, maybe for the machineries, or maybe for processes, is nothing but a pure waste. So synchronizing workflow as much as possible, balancing uneven loads, proper sequencing of the task of manufacturing. With the help of that, this waste can be eliminated. Third waste is waste of transportation. So redesigning the layouts, then best possible layouts between the sources and destination using the transportation model or any other mathematical model to make the transport and handling unnecessarily, that can be eliminated. Fourth is waste of processing itself. So need of assessment of the products and processes can be studied, and this can be waste of processing itself can be eliminated. Fifth waste is waste of stocks or inventories. Reduce the setup time and lead times by synchronizing the workflow, and unnecessary stock or waste of stock can be eliminated. Sixth waste is waste of motion. Study the motion for economy and consistency, motion of the processes, and after the study the motion, you can eliminate unwanted exercises or unwanted actions by the workers or processes. Then last is the waste of making defective parts. So there are again various mistake proofing techniques that can be studied using Pokayuki Japanese technique or other techniques. And waste of making defective parts can be eliminated by preventing the defects or to eliminate the inspection. So this is how the waste can be eliminated. Now, next is the value added manufacturing framework that is based on several principles. These principles are: take a broad view of operation as a process, then analyze the problem and make problem visible to everyone so that if there are solutions, that solutions can be suggested by each and everyone who are working there. Then instead of complex, keep it simple. Maybe the processes, manufacturing processes, everything should be kept it simple, and but still it should be effective. Next is improve operations. Sorry, improve operations before spending on new plant and equipment. And last is just focus on flexibility in the production so that uneven demands and supply, still the production efficiency can be maintained. So these are some value added manufacturing frameworks based on few of the principles. Now this figure talks about the manufacturing excellence through value added manufacturing, and there are few points like just in time manufacturing, total quality management, and total people involvement. So the framework of value added manufacturing is described in three overlapping categories of the work. As you can see in the figure, total quality, just in time, and people involvement. One cannot be successful with just in time or total quality management without the total people are involved in that, and vice versa is applicable to all. Each of these is characterized by some of the basic functions. First, we'll talk about total quality control. So, there are some concepts for total quality control. First is begin with the customer. Whatever customers are expecting, you have to understand the customer wants or needs, and then you have to act accordingly. That is called as begin with the customer. Do not produce the thing which are not needed by the customer and just forcing those products and services to the customers. That will not help for long term. The second is measure and track quality of the products. Take a broad overview of the overall quality. Set targets for further improvements. Responsibility at source is also important. Then standardization maintains a good practice and prevents problems for further recurring. And lastly, fail-safe operations. So using these principles, total quality control can be achieved by the manufacturing processes. Next is just-in-time manufacturing. So only the right materials, parts and products in the right place at the right time. If you are achieving this, then you are trying to be closer to implementation of just-in-time manufacturing. Last is total people involvement. So here the concepts like broad perspective, problem solving atmosphere, employment security, and performance measurement. So value added manufacturing is a philosophy of competitive advantage through the development of people. In complex manufacturing, the best advantage comes from what people can do that competitors cannot. It is not quickly established, but once firm in place, it is not quickly destroyed either. Next is Schonberger's framework of world-class manufacturing. According to Schonberger in 1986, the goal of world-class manufacturing is continual and rapid involvement. He argues that continual improvement in quality, cost, lead time, customer service, and flexibility will lead to world-class status for that organization. The world-class manufacturing status can be achieved by any of the two parallel paths, either quality path or just-in-time production path. These two dominant world-class manufacturing perspective for treating the alignment. The just-in-time percept is based on the just-in-time principle. Smaller the lot size, the better. World-class manufacturing of cars, tractors, and motorcycles have some of the lot sizes down to 1 unit by becoming accept and adapt at the changeovers between the models. The second percept is total quality control, that is TQC principle, do it right at the first time. The third set of perspective is called as total productive maintenance (TPM), a regime of comprehensive maintenance activity carried out largely by operators of the equipment and not by a maintenance of specialists, the objectives of which is to ensure the zero downtime of the equipment. While the just-in-time concept is natural in flow industries, it can work in discrete good manufacturing also. A world-class manufacturing precept is to produce some of the every type every day and in the quantity sold that day. Making more than that can be sold costly and wastefully. The cost and waste is magnified manifold as resulting the lumpiness in the demand pattern ripples back through all the prior stages of manufacturer, including on the bid supplier. In Schonberger's opinion, if world-class manufacturing efforts fail to make it easier for the marketing to sell the product, then something is wrong. He advocates for the cellular manufacturing, deviation reduction, and variability reduction. While cellular manufacturing will help to achieve the improvement in quality, cost, delays, flexibility, worker skills, lead time, inventory performance, scrap equipment, uptime, and host of other factors, deviation reduction should take care of zero defects and reduction of lead time. After Schonberger's frame of world-class manufacturing, we are having the famous guns model of world-class manufacturing. So, according to researcher Gunn in 1987, world-class manufacturing rests on the three pillars: CIM, that is Computer Integrated Manufacturing; TQC, that is Total Quality Control; JIT, that is Just-in-Time Production Methods. There are three fundamental approaches in modern manufacturing which may enable a manufacturer to gain competitive advantage for reaching world-class status. He proposed Arthur Young's manufacturing for competitive advantage framework to illustrate his point. You can refer this figure. This framework starts with a business unit's strategic vision at the top, which embodies the overall business objectives of the unit. This vision is based upon two different frames of reference. The first is that the global markets in which the manufacturer competes, and the other is that of the global competitors. So, guns manufacturing for competitive advantage framework. The next level in the framework is integrated manufacturing. This is one dimension of the entire range of activities consisting of product and process design to manufacturing planning and control, to the production process itself, to distribution and after sales service, and support, and the other dimension consisting of customers and suppliers. The framework also shows that the main interference from the integrated manufacturing has been through the distribution function. However, according to Gunn, all the five functions within the manufacturing should be engaged in an ongoing dialogue with their customers. The fact that CIM, TQC, and GIT are shown together and equally under integrated manufacturing in the framework has some important implications. First, by showing CIM and GIT together, the indication is that there is nothing mutually exclusive about the two, nor there are anything mutually exclusive between JIT concepts and manufacturing resource planning, a part of CIM. Moreover, by showing all the three together, it is implied that all three must be addressed at once in any overall program to gain competitive advantage in the manufacturing. For manufacturing, the manufacturing for competitive advantage framework provides logically rigorous, complete, and yet easy to understand view of global manufacturers' environment. It can be used as a mean of discussion in order to appraise whether the company is addressing all aspects that is taken to become a world-class manufacturer. Next concept is Maxwell's model of world-class manufacturing. According to Maxwell, world-class manufacturing generally includes the following: a new approach of product quality, just-in-time production techniques, change in the way the workforce is managed, and flexible approach to customer requirements. In terms of quality, the world-class manufacturing approaches emphasize on the resolution of the problems that cause poor quality rather than merely detection of these problems. The purpose is to systematically resolve the root cause of the quality problems so that the company can ideally achieve zero defects or 100% quality. Second aspect of this new approach is that quality control responsibility is placed on the floor with the production operators. The operators are responsible for doing their own quality control, and pride of ownership attitude is fostered. Now you can see on the screen the purpose of JIT manufacturing is to change the production so that inventory not immediately required for production is eliminated. This goal can be achieved by: first, change of shop floor layout to reduce the movement of materials; second, reduction in production setup times so that products can be made in very small batches; third, synchronizing the manufacturing processes so that sub-assemblies and components are available just when they are needed and not before or after; fourth is creating mutually beneficial relationships with suppliers using techniques such as single sourcing, certification, and openness. So, people management is most difficult problem to solve when introducing the world class manufacturing, as it requires fundamental changes in management style and philosophy. Some of the new approaches to the management of people are: first is transfer of responsibility. A world class manufacturer should give operators greater control of their daily work. They will have prime responsibility for conduct quality, scheduling, preventing, maintenance, and for attending production targets, education and cross training. World class manufacturers spend a lot of time and money to educate their employees in areas such as GIT manufacturing, quality control, and along with that, the customer service, as well as train them to do a wide range of tasks within the production plant. This cross training of people allows greater flexibility because operators can be moved between the tasks. The third is problem solving and quality circles. The purpose of quality circle is to have every employee involved in solving the production or other problems. These programs have been very successful in many companies because they create an environment of team involvement and common cause, which enables people who previously had little opportunity to contribute to become innovative and resourceful problem solvers. As for flexibility, there are two important aspects. First is production flexibility, next is design flexibility. We'll see one by one. First, we'll talk about production flexibility. It is achieved when the company can offer short lead times, when the product mix within the plant can be changed significantly from day to day, and when people within the plant are cross trained to manufacture a wide range of products. A company that can offer this level of flexibility to the customer without a price penalty has a significant competitive advantage. Next is design flexibility. It is related to company's ability to introduce new products and modifications to the current products. Company must be able to understand the current and future needs of the customers to develop innovative products and to get those products to marketplace quickly. Last part is no second last part. Last part is Malcolm Baldrige Award. So before that, we will just finish the America's Best Plants model for world-class manufacturing. So Industry Week conducts a survey of American plants to identify which of them are world-class. So whereas the questionnaire for this survey was very detailed one, the characteristics of world-class manufacturing are identified by three core strategies: customer focus, quality, and agility. Again, we have seen agility is the ability to quick and efficiently and effectively respond to the changes that occurs. These form the foundation of best plant performances and six supporting competencies like employee involvement, then supply management, technology advance, product development, environmental responsibility, safety, and corporate citizenship. The supporting competencies help the plants achieve the goals defined in the three core strategies. The three core strategies are at the same time both philosophical and tangible goals. Consumers' focus has always been a primary requirement of the business. Customers should occupy the center of the manufacturing operations in the best plant, and customer is the king. Quality is the second core strategy. In the America's best plants, quality is viewed as the defect-free, waste-free workmanship that derives from the product and process quality. Lastly, agility has been defined as lean manufacturing and just-in-time supply practices. Flexible production structures, fast clean slate processes, redesign as advocated in reengineering, and mass customization production strategies. The six supporting competencies of the best plant assist in the achievement of the three core strategies. The supporting competencies recognize that a manufacturing plant is more than a simply production line that converts raw material into finished goods. It is a living system that has impact far beyond the walls. Best plants are also the people who work in them and the vendor who supply to them. There are technologies that support the operations and the new product that create. They have an effect on the environment and communities in which they operate. The famous Malcolm Baldrige National Quality Award. So, good management has generally been recognized as the necessary for achieving a world-class competitive position in the manufacturing sector. With the rise of Japanese companies and more recently that of firms from the Pacific Rim countries, increasing attention has been given to excellence at the operational level. Many awards created over the last 40 years to promote total quality management as the mean of achieving the manufacturing excellence and thus reaching the world class status. The first one was the Deming Prize in Japan, created in 1951, and the Malcolm Baldrige National Quality Award established in 1987, the best known and most comprehensive award in United States. The Baldrige Award is used as many as a benchmark. The quality criteria are built upon the following core values and concepts. These are customer driven quality, leadership, that is continuous leadership and continuous improvement, then full participation and fast response, design quality and prevention, then management by fact, partnership development, and public responsibility. Along with that, these core values and the concepts are embedded in the seven categories in attending the global quality standards. So these seven categories are leadership, information and analysis, strategic quality planning, human resource development and management, management of process quality, quality and operational results, and last is customer focus and satisfaction. The Baldrige Award offers a demanding competition with every company subject to the same stringent tests. The award has created a common vocabulary and philosophy bridging the companies and industries. Managers now view the learning across the boundary lines of the business as both possible and desirable. So, with this, we have finished the small unit that is